Okay, welcome everyone to this new episode of the podcast Coffee Breakdown. I am Luca, and today we have two new guests. Tiago Dias, who's a PhD student from Instituto Superior Técnico in Lisbon, and Maik Budde, who's a joint PhD at TU Eindhoven in Lisbon. So welcome, guys, and thank you for being here.
Yeah, thanks for having us.
Thank you.
Yeah, so, well, first of all, let's start with some ritual questions to both of you, maybe starting from Tiago and then Maik. If you can introduce a bit yourself. Where are you actually right now? Because you are in the same room, I see. And what are you doing in your life?
Okay, so as you told, I am a PhD student, and currently I am working in Lisbon. So most of my work is done here in Lisbon, and I work in low temperature plasmas, and I'm in the third year of the PhD.
Okay.
Currently, we are actually in the same room and working more or less on the same thing. Currently, we are doing modeling work here at Lisbon.
Okay.
Yes, as you said, joint PhD student. I moved here to Lisbon September last year. Before that, I've been working in Eindhoven, in the Netherlands.
Okay.
Yeah, as Tiago said, basically here it's a lot of computer work, getting the electron kinetics in a low temperature plasma in place, and then spice it up with some chemistry to get a complete description of what is going on.
Okay. Actually, since so, Maik, you've been also moving to different places, like Eindhoven, also Germany, and so on here. How do you find? So, do you find some differences in terms of work or life in general, or is it kind of the same?
Yeah, no. Of course, there are differences. Yes, as I said, I studied in Germany, then I moved to the Netherlands, and in principle, the cultures in the Netherlands and Germany are pretty close. As one might expect. What actually was the hardest for me is the Dutch mentality about lunch.
Yeah. I know. I experienced that, unfortunately.
Yeah, it's a mess. So what they eat for lunch, I wouldn't consider food, to be very honest. Just not enough. But the working mentality is pretty similar. Here in Lisbon, I have to say people are a little bit more relaxed than back up north, and I really appreciate the relaxed atmosphere here.
Okay, so you think it's also better for research, probably a bit more relaxed atmosphere than having.
I think it depends on your own style of working.
Okay.
And for sure, you always have to adapt. Here, you have to be really determined and motivated to really keep going, because there's no one pushing you around. But yeah, you're right. For many things, it's very pleasant.
Yeah.
It's better for the personal life.
Yeah, it is.
Yeah. So, and one question that kind of interesting also. Suppose I come to visit you guys in Lisbon after the pandemic. What do you recommend me to visit or to do in Lisbon? I think it's a great city, and is there something to do that you think is nice?
Actually, several things. I would say the city is really beautiful. So many things and you should take at least a week to be here and visit. So
I've been there for a few days only. I think it's. I went up to a tower with the elevator. I think it was very popular for tourists, probably.
Yeah, indeed.
I don't remember the name.
And okay, in the downside of the city, right?
Yeah.
Oh, okay.
Yeah. And then you have this great pastéis de nata. I don't know if my pronunciation is correct, but
yeah.
I miss that a lot as well.
Pastéis de Belém, yeah.
Okay.
Yeah, and the great thing of the countries here in the south of Europe is really the sun.
Yeah.
It really changes your way of living, in my opinion.
Yeah.
Since I know the comparison, I can completely agree with that.
Yeah.
Okay. Okay, so coming back to your work, where you actually already mentioned a little bit, if you can tell us which application are you working on at this moment, and how are you approaching it? So which method are you using to investigating it? So maybe, yeah, we start with Tiago, then Maik.
Yeah. Okay, so as I told you, currently I'm working with these low temperature plasmas. So plasmas which are basically mediums, media with electrons and ions. But then we have also several neutral molecules, and so we can do several things that are good for the industrial point of view, because we can have a high non-equilibrium which can be used for chemical processes that are good for the industry. And currently I'm working on a type of low temperature plasmas, which is called nanosecond discharges, which are the discharges which are very fast with very high electric fields, and that can be used for this industrial point of view, because they can be very efficient. And I'm studying them from the modeling point of view until now. So basically I solve the electron kinetics and the chemistry, everything at the same time, using a method which is called Monte Carlo integration, and it is mostly that. And starting from May, I will be in Prague doing some experimental work.
Okay.
In order to know this type of discharges from both points of view.
Okay, that's very nice, actually. Okay. So this is like atmospheric pressure, or you're working at the lower pressures?
It will. I'm not sure yet what I will do in the experiments, but maybe not high and neither low. So in the medium side.
Okay.
I don't know for now. Yeah.
Okay. Yes. You mentioned you develop also some codes and so on. That's okay. Very interesting. So, okay, Maik, and you? Are you doing the same topic or different?
More or less. So while Tiago is really universally skilled in treating these electron kinetics and everything, I'm working a little bit more specifically on one particular type of plasma. Namely, I'm interested in CO2 plasma for the purpose of converting this CO2. And to make it more interesting, we are adding water to the plasma. The idea is that water is everywhere as an omnipresent impurity. So we have to understand what's the influence of it. And well, back in Netherlands, I investigated the whole thing experimentally with some laser spectroscopy.
Okay, so this is not a nanosecond, but is a nanosecond pulse,
no,
is microwave IT.
It's a much simpler discharge. It's a pulsed DC glow discharge.
Okay.
So it's basically the most simple plasma that you can imagine, probably. The reason why we're using it is that even though it's so simple, it still shows the characteristics that we want to have from this low temperature plasma, namely a non-equilibrium between the electrons and the heavy particles. And due to its simplicity, it's easily accessible for the diagnostics, but it's also perfectly suited for modeling purposes. And well, right now, I think during this discussion, you already noticed that the electrons are the very foundation of everything that happens in the plasma, right?
We also had some of the previous episodes talking about plasma chemistry. So you mentioned it's simple, but actually, talking about CO2, water already, and it's a lot of complicated chemistry.
It's a mess, and since the electrons are so important, we need a proper description.
Okay.
So and one approach, in contrast to the Monte Carlo that Tiago is working on, is to use a two-term solver of the Electron-Boltzmann equation to describe the electron kinetics. And for this solution, you require cross-sections. Cross-sections that describe the most relevant processes between electrons and water molecules. And to this point, there's really no really satisfying and openly available set of cross-sections for water. And I try currently to establish one.
Okay, that's very nice. So suppose you have to pitch in, I don't know, a few seconds, you know, your work, and say, what is the most interesting thing that you have been working on, even if it's just a small part, and what is the most important that you think? You mentioned already, of course, what you're working on. It's just which part of your work did you enjoy the most?
I can answer. So in a few seconds, I would say that it is this description that I am doing of solving the electron kinetics and the chemistry of the heavy species at the same time, without any approximations, which is something that is new. And I have some prods regarding that, and I guess that it is important.
Okay. Actually, it's interesting because I've also been working, you know, development of codes for different purposes. So are you more, do you like more a bit the development part, you know, starting from paper and developing, or really the part where you take the code, you apply to the relevant case of study? You know, I don't know, it's personal preference.
That's a very nice question. Yeah. Okay. And actually, I really like the development part. So I really like to develop. So think about the science of the thing in a general way. So we have a general set of cross sections, a general set of reactions, and then when I finish the development, which is for me is really funny. Then I use the data that someone like Maik got.
Okay, but that's nice.
That's what I like the most. It depends on the person.
Okay. And you, Maik, did you like more the experimental part or the modeling just so far?
Rather good question. I think I'm more an experimentalist. Even though what's very nice about the code is that you have everything in your own hands. So in the lab, usually the biggest screw up is that your equipment breaks down at one point, or something is simply not working, and you cannot do anything about it, or you have to spend quite some time to fix it. While working with the code, the nice thing is you have your computer, you write yourself some code, and it's running or not, but it's all directly under your control. That is nice.
Okay. So you're less dependent to other people, actually. So you can fix it if it doesn't work and so on.
And I mean, the dependence on people does not change. So you always benefit from discussion with experts, but you are less dependent on the equipment.
Okay. I want to start, really kind of the core discussion with you is just thinking about, some sort of personal opinion about where are we going as a community, what are we going to approach and so on in the future, and this is not something that wrong or correct, it's just opinions that we are going to share, I think. And so in particular, like currently, I feel, my heart is a little bit divided. So if I go to conferences, I see a lot of interesting applications, like, I don't know, all thrusters, plasma medicine and so on. That is very nice. But also I like really much a more fundamental part in the sense, I don't know how you describe transport of charged particle in a gas, how you define cross sections, as you mentioned, and so on. So do you think our community is a bit more application oriented or a bit more, driven by fundamental studies? at the moment. I talking about just low temperature plasma community, of course, not all the science.
This is really a very interesting question and very present in our times. Actually, we already discussed it here in our group several times, because every time in this community, we are always thinking about the next project. What is the application of that we will find of the low temperature plasma to gain another project? Because if you don't have money, you cannot do science, and it is a very complicated thing. On the other hand, as we talked actually this week, it's a very thin line, because if you let everyone do whatever they want, then they will start to procrastinating, and they do not have a good path. So I'm not sure that there should be a balance. So some people that care more about the fundamental points of views, because otherwise, if we are always worrying with the applications, the science does not move on, in my opinion. But it cannot be everyone, I would say.
Okay, Maik, you have something to add?
Yeah, let me think. So I definitely think that the plasma community is going more and more into this applicational direction.
Yeah, I also have this feeling, but I also agree with the fact that, of course, we should pursue both, right? Yeah.
We should pursue both, yes. In my opinion, one of the reasons is that there have been a few really big success stories of plasma applications. Take, for instance, the production of ozone with amazing, still today, extremely relevant in the industry. And that is, I often feel there's this expectation from the funding agencies that plasma might provide another big success story. So it's really hard, I think, nowadays to really get the funding for the groundwork only, but you have to have this application in mind. And then I absolutely agree with the two of you. Then we need both. We need the application studies, but also we get the fundamentals in place to really tailor the processes accordingly.
I think I agree. I agree with both of you. I don't know. I think in my perspective, it's great that there are so many different applications, you know, and that plasmas have a potential to break through, also to have a societal impact. And this is for sure important. And also, I think fundings at this time probably are a bit more driven by application purposes. Nevertheless, sometimes, and here maybe I'm a bit pessimistic in this respect, but I have a bit the fear that if we narrow down only thinking about applications, sometimes we miss a bit the bigger pictures, you know. We may, so this is why probably we also need people doing fundamentals, like thinking what, you know, start tackling some bit more fundamental questions that do not have a specific purpose application in mind.
Do you have something in mind?
I don't know. For example, there is something that fascinates me a lot. That is a transport of charged particle in liquids. That we know quite well to describe in rarefied gases. You know how to describe particles, but if you move to liquids, for example, this binary collision approximation breaks down. You have some sort of more collective effects of a particle, we have sort of cluster of particles. This is very fascinating. Or in dense gases, for example. I saw work of people studying transport of charged particles in dense gases, a bit more similar to what happens in superfluidity. That is something we don't know. We don't have a theory for that, right?
Yeah.
How is that applicable? Yes, I can think about application of plasma in liquids, right? But you know, it's just for the sake of knowing how this mechanism happen, you know.
Yeah, and maybe after you know this mechanism, you can find the application. That's the thing.
True. That is true.
If you are always thinking about the applications, you do not move on, because maybe there is an application that you do not know and that you will find in your fundamental study.
Yeah.
Like
Actually,
the great scientists, it was like that. The things that Einstein was doing at that time, no one would say that this will have an application in lasers, or to correct the distances in the GPS. So, and now it is completely important.
yeah. I'm curious also to you if you know, you've also been in conferences and so on, workshop, whatever. Maybe Maik and Tiago. So do you have an example of applications or fundamental studies that you think are very interesting besides the one that you are studying, of course, besides the one that you're working on?
I always loved plasma medicine.
Okay, yeah, it's very...
It's a very, very interesting field, and I actually, it's more like that. I hope that there's more to come. Often it feels really like magic what they're doing. So it's often just put some plasma on something, and usually it improves, which is great. So I see really some potential there, but the future will show whether this really becomes something big.
Yeah. Tiago?
Actually, I guess that is really this biomedicine thing is really, I guess, the main thing that will be very important in the next years, I would say.
Yeah.
Because from the industrial point of view, we already know that that the plasmas are really important for this nitrogen, for the production of fertilizers, and also to build this kind of devices like cell phones to produce the chips. But those applications, we are already know them very well. I guess that the recent trend is really with this biomedicine.
I'm also very fascinated by that plasma medicine. I saw recently also application in plasma agriculture that I didn't know. It's but for me, one of the problem, I don't know, that should be tackled is maybe the reproducibility, you know, of the results. So does the plasma really have an effect? It can be reproduced, you know, because then when you apply it to, you know, a medical lab or so on, or to a patient even, you need to know the effect exactly, you know, if statistically is relevant or not. I don't know. I think there is still work to be done in that area for sure. Okay. And one other thing, really a bit connected to, still, you know, fundamentals and application and so on. The other fear I have, let's say, and so on, is that, in my opinion, this is not to blame, but people in 20, 30 years, you know, we tend to forget, you know. So in my opinion, you know, if we don't set very well the foundations of the field, and everyone is using, you know, kind of the same model with the same assumption and so on, I have the fear that, you know, in some years we forget that there are other options, other model, other assumptions that we can investigate. So what do you think about that? Is there this, do you think there is this problem in our community, or is it something that is not really relevant?
I guess that there is really a problem here. I remember really on the first hand the two-term approximation. This approximation that we use, assuming that the electric fields are low enough such that these anisotropies are not very high. So almost all the codes use this approximation, and we have like this commercial codes that use it, and many people are using it, and they already assume that it is fine because everyone is using it. And then I guess that people forget the basic things and do not bother with it because the code is already done. And sometimes we are doing very big mistakes without knowing. And it is very, very dangerous because like you told, 30 years ago, probably there were lots of people knowing about this legendary expansion, but now almost no one knows it, and everyone uses this type of thing. And there are for sure many other examples of what you are saying. So I agree completely with you.
Yeah.
Yeah.
Maik,
yeah, you talked about general guidelines for the community, and I absolutely agree. They should be these guidelines, but it's so difficult in my opinion, to introduce it, because every group, they have their own kind of way of approaching things, and even within the groups, it's often hard to find an agreement on how to define the things and how to properly treat the things.
Yeah.
So,
But I was sometimes, well, as you know, in our channel, I'm doing this channel with a friend of mine who's mainly talking about fusion. And I've been talking also with people doing fusion, and okay, probably their community is a bit less scattered than our community on low temperature plasmas. But they started some interesting activity, you know, about sharing data, like both modeling and also experimental data that are from different machines. And also having some sort of common framework that you use for modeling some type of machines, you know, that is agreed, for example, at the European level. You know, this is then of course, this should not prevent to have diversity, I think, in research. But do you think something like this, you know, have frameworks to share more data and also have codes that are available in the community that we decide, you know, this is the way we model the cycle discharge, this code is appropriate? You think are useful, that we should push for this direction? Or do you think it's a bit more useful to keep this diversity, you know, that every group is kind of studying different aspects?
I agree with you. At this point, we have many people doing more or less the same thing, but one is using one code and the other is using other code just because, okay, they are more used to the inputs and these kind of things. And I guess that it's not the most efficient way and the most organized way. I know that LXCAT, so our database for our field, is trying to go in this direction, but is still not enough. And I agree completely with you. Yeah.
You, Mike, you think like I don't know, like open sourcing or these kind of things could help the community to progress, or is it something that is not really necessary at this point, that we could still do good research without, you know, having big frameworks?
Yeah, that's for sure. You can do good research. Yes, absolutely. But I think this and as you said, organizing frameworks, also the funding agencies, they are putting more and more attention on this, that if you want to get the money, you have to provide good organization of your things. And I think, yes, research would benefit from it, because it forces a structure upon the things they are doing, and that makes results reusable and facilitates the comparison between different groups. So yeah, I think it's a good thing.
Yeah. I think also in my opinion, because, you know, maybe I don't know, as a physicist, I would like to have a model that is more and more accurate, that can describe the experiment well. I would also like to have measurements really detailed, really accurate for every position, you know. But at some point, I think we might have also to realize that there are a lot of parameters that we cannot control, right? We don't know how really particles interact with the surface, how they propagate and so on. And, you know, there are some assumptions that we have to take. So maybe our models can be also a bit more conceptual, you know, not really super accurate on the physics, a bit more conceptual, but still we can get some feelings on the physics or what can be important, you know, and so on. So I think still, yeah, you know, if we don't know everything, I think we can still do good research, you know.
Yeah, it's another very good comment, because I guess that at some point we are always trying to put the experimental points on top of the
exactly
modeling.
Just for validation and so on.
But I guess that what it's, and we always tell this in our group. What is the most important thing is the trends that you get from the modeling, what you learn from the modeling, and what because this is really the most important thing. When you have these modeling results, you will learn how to make your configuration more efficient, and many other things. But we have really to realize that there are experimental errors, that the coefficients that we put as input in the model also have errors, and even the assumptions that we do, like when we are constructing this model. So sometimes when we are trying to change these input values in order to have the experiment on top of the modeling, maybe we are doing even worse, because we are changing something that it is fine in reality.
Yeah.
Thanks, Tiago. I say that because this is exactly what I'm doing at this point.
No, but I mean,
parameters to get an agreement. Yes.
No, I totally agree. I had this thing, you know, sometimes I also maybe did some work and so on, and people say, yeah, very nice. You see this comparison between experiments and your model, and it fits really well. And I think, yes, I'm glad, but there are so many assumptions behind, you know, and but then I have to deal with it, you know, and see, you know, I use this assumption, maybe they're strong, but I can still get some insights into what happens, you know, if I take these assumptions. That's I have a question for Maik. Suppose you're saying you are, you know, studying this type of discharge, you know, the glow discharge. Suppose you want to model that or describe that, the main physics principle or chemistry, you know, what are the data that you think we need absolutely, that are very important to measure or to know, you know, that are used as input in the model or for validation of the model, you know, as post-processing. There are some quantities that we need absolutely to know, or maybe that we don't know and we need to measure or we need to calculate.
Yeah. Well, according to the papers that I'm writing, especially the most important things is always number densities of particles involved. So I measure them, and then I want to compare them with the model, and then it is about, in my opinion, getting from the basic, the ground state particle to more and more exotic species, and by this like really go into the details of your model. So, for example, looking at the CO2 plasma, there the vibrations are very important, and we started with only very small number of vibration levels that are included, and now we are always looking for some measurements that go up higher and higher in the vibrational ladder to really validate our models to the core.
Okay. Okay, that's interesting. Okay, and well, you, Tiago, you have some opinion right now from modeling perspective, also from experiments that you're going to do.
What is very, very important really in the beginning is to have really good electron cross sections. So otherwise your model will fail. This is a very important thing, not to compare between modeling and experiment, because it is really an input for the model. But if you don't have this part of the electrons, which are the ones that drive the whole dynamics of the plasma, you don't get the right trends and the right physics, and this is really important. And it's not very easy to obtain experimentally. Especially the absolute value. Sometimes it is normalized because they look for the signal of an excited species or something, and they cannot normalize. And this is very important for the modeling in order to have to learn from the model, because we are doing the things right. Yeah.
Okay, very interesting. Okay, maybe then to conclude, I would like to have a bit your opinion, your feeling about this, this last period, last 2 years actually, unfortunately, when we had COVID and so on. And I was also working mainly from home. I'm still working from home. And sometimes it's a bit frustrating, you have a bit less interaction with people, at least for me, and also time seems to pass in a bit different way. So what do you think? How did you spend your last 2 years basically of doing research, or your own life actually?
You want to start?
Yeah, sure.
Yeah.
You're absolutely right. It has been strange times, and I can only say for me, I always try to make the best out of it, and I think that was the only option that we had. So there were no in-person meetings, but then we switched to online meetings, and actually I think this is something that was actually improved due to Corona, showing that many things can be done.
Yeah, that's true. That's a positive thing. I agree. Yeah.
Nevertheless, of course, I miss the in-person meetings and the conferences. Absolutely. Work itself, as you said, there was a lot of working from home, and being an experimentalist, that is of course hell.
I can imagine. Yeah.
As you can imagine, but having the modeling work also at hand, this is of course something that is that can be better brought in agreement, so you still feel like you're progressing in your work, even though you don't spend every day in the lab. Yes.
Yeah, true.
How was it for you, Tiago?
I guess that the first year was worse, because almost all the months of the first year were done at home, and you may think that you are more efficient at home because you don't lose time to go to the university and come back. And it can be like that in the very first days, but then you start missing this personal context that is not enough with Zoom meetings. You really need to see to see people in person, to have lunch.
Exactly, have lunch, get a coffee together, and so on. And I think,
and then you are working less hours, but you are much more efficient. You are happier, and I guess that it is really important. Some people may be very good working at home, but I guess that most of us benefit from working here. I guess that it was good to realize that some days we can work at home, and to put this idea on the trash that if you are not in the working place, you are not working. I guess that this
Yeah,
is
yeah.
not.
I think this is something that opened my eyes as well. You know, I had this mentality. Yeah, I have to be kind of early in the office, start my work, and then finish it.
Yeah.
But no, I mean, I can also some days stay at home and so on, be a bit more relaxed and so on. Another day, go to the office, talk with the colleagues. I think this is a positive side. Okay, if we have to look at the optimistic view, I agree. I agree with you.
Should, right?
Yeah. That's a nice thing.
But in terms of like a meeting, like conferences, workshop, and so on, do you think like, I don't know, for example, if I'm in a conference, I go to get a coffee, I see this big professor and I say, yeah, I like your work, or I ask a question, you know. If I am online, I typically tend to not ask so many questions as I would do. I don't write to the chat to this professor, you know, that I don't know. So what do you think? Do you have the same problem or?
For sure.
Yeah.
So we started the PhD 2 years and something ago, and we had no, at least me, I had no in-person meeting conferences. So this is really a problem. So my first conferences in person will be this year, and I didn't meet these very important persons in our field because of that. And even more important, they didn't meet me. They didn't meet me, so they don't know what I am doing. If it is relevant
maybe they still see your work. You know, you presented at conferences, so it's not so bad as we may perceive, right? Yeah. But of course, this social.
It's not the same thing.
It's not the same thing.
People do not pay the same attention when they are in a virtual presentation, I would say.
Yeah.
At least that's what I feel. Because after sometimes I start thinking about other things, and I imagine that this also happens to other people.
Yeah.
And also when you are the speaker and you cannot see the people that you are talking to, it helps so much to stand in front of a crowd and see some people nodding, so you know, oh, you're doing something right. Or
that's true. The feedback is very important.
So, maybe I should go a little bit slower here.
Exactly.
In online meetings.
Yeah, exactly.
Yeah, I taught 2 years in thermodynamic course, and it was online, and it was
it's
so
different.
bad because I didn't know if the students were listening to me, or maybe they were in the bed sleeping with the computer turned on. I didn't know that, and talking to a black screen is very difficult.
Okay. Yeah, I think I agree. Okay, guys, thank you very much. It was really nice talking with you, and well, see you soon. Actually, see you in Lisbon, hopefully.
Yeah,
okay.
that would be great.
Bye.
Bye.